Dear students, welcome to Digital Logic and Computer Design. We are going to start with Unit 4. So in this session, we are going to study about synchronous sequential logic and registers and counters. So in the first session, we are going to see what is a sequential circuit, what are the types of sequential circuits. So sequential circuit can be defined as it is a combinational logic circuit that consists of input variables, logic gates, and output variables. A combinational circuit produces an output based on input variable only, but sequential circuit produces an output based on current input and previous input variables. So it means for sequential circuit, current input as well as previous input is very important. That means sequential circuit include memory elements which are capable of storing binary information. That binary information defines the state of sequential circuit at that time. A latch is capable of storing 1 bit of information. So this is a circuit diagram for sequential circuit. You can see we are passing inputs to the combinational circuit and it is producing outputs. So here you will see external inputs are given to the combinational circuit, and there is a memory element which will store the next state, and this memory element again is given back as an input to the combinational circuit. So from the circuit diagram we can find two types of input to the combinational logic. One is external input which is not controlled by the circuit, and one more is internal input which are the functions of a previous output states, and one more is secondary inputs are states variable produced by the storage elements, whereas secondary outputs are excitation for the storage elements. Now let us look at types of sequential circuits. There are two types of sequential circuits. One is asynchronous sequential circuit and another one is synchronous sequential circuit. First one is asynchronous sequential circuit. These circuits do not use a clock signal but uses the pulses of the inputs. These circuits are faster than synchronous sequential circuits because there is a clock pulse and change their state immediately when there is a change in the input signal. It means it operates with the help of pulses of the inputs. This is a circuit diagram for the asynchronous sequential circuit. You can see here there are input levels and it is producing output pulses or levels. Second one is a synchronous sequential circuit. Synchronous sequential circuit. This circuit uses clock signal and level inputs are also called as pulses. The output pulse is the same duration as the clock pulse for the clocked sequential circuits. Since they wait for the next clock pulse to arrive to perform the next operation, so these circuits are a bit slower compared to the asynchronous circuit. Level output changes state at the start of an input pulse and remains uh, in that state until the next input or clock pulse occurs. This is a circuit diagram for a synchronous sequential circuit. So difference between asynchronous and synchronous circuit is that it uses clock pulse. You can see here a clock pulse is passed to the sequential circuit along with the input level, which is going to produce some output levels. Uses of synchronous and asynchronous sequential circuits. We use asynchronous sequential circuit when speed of operation is important and independent of internal clock pulse. Means when we need a faster operation and when we don't have to use the clock pulse, then we go for asynchronous circuit. We use synchronous sequential circuit in a synchronous counter, flip-flops, and in the design of Murray-Milley state management machines. So now let us look at the differences between synchronous and asynchronous circuit. So uh, all the state variable changes are synchronized with the universal clock signal. This is with respect to synchronous circuit, whereas the state variables are not synchronized to change simultaneously and may change at any time irrespective of each other to achieve the next steady internal state. Second difference is, since all the internal state changes are in the strict control of master clock, so they are less prone to the failure or to a race condition and hence are more reliable. Indirectly, we can say that synchronous circuits are more reliable, whereas asynchronous circuits are not more reliable. Third one is, timing of the internal state changes are in our control, means we have the control over internal state, whereas in asynchronous circuit we do not have a control over internal state. So let us summarize. So we started with the definition of sequential circuit, then we have seen how the sequential circuit works. Then we started with types of sequential circuit. We have seen what is asynchronous sequential circuit and what is synchronous sequential circuit. Apart from that, we also studied what are the differences between synchronous sequential circuit and asynchronous sequential circuit. So let us look at the questions on synchronous and asynchronous circuits. A sequential circuit produces an output based on current input and dot 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 variables. So the options are next input, previous output, previous input, current output. So obviously it based on current input and the previous input. Dot dot information defines the state of the sequential circuit at that time. So binary information defines the state of the sequential circuit at that time. Third MCQ is, in synchronous circuit, all the state variable changes are synchronized, whether the given statement is true or false. So it is uh, obviously we say that synchronous circuit, all the state variable changes are synchronized, so the given statement is true. So these are the references. Thank you.